generated content might be incorrect. Started by you, let everyone know that they are being recorded. Oh, sorry. So let's look at the Maclaurin series. At the end of this learning unit, you should be able to use the Maclaurin series to derive series of common functions. So I want you, let's read here only. Sometimes it is important that a function can be expressed as a series of ascending powers of variable. You'll go and read there, everything. Me, I'll start here where it says, the Maclaurin series is then given by f of x is equals to f of x plus x times the prime of x, this one times that one, this one times that one, plus dot, 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 just to show continuous. Then they say, notice how tidy each term is. The term x squared is divided by 2 pi and multiplied by the second derivative. The term x to the power of 3 is divided by 3. Why am I saying pi? 3 factorial multiplied by the third derivative, and the term x to the power of 4 is divided by 4 factorial multiplied by the fourth derivative. Guys, are you hearing me?
Yes, ma'am, we can hear you.
Yes, ma'am.
Okay.
Yes, we can.
Now, do you see that when you are writing the fourth derivative, you don't write y prime, 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 right?
Yes.
You can also write a number as like the fourth derivative, something like this, or the fifth derivative. Yes. Now, here's a question that says, okay, fine, I need to erase here. That says, expand. This is one of the questions that you should be getting in the exam by just closing your eyes. They say, example, expand sine x in a series of powers using the Maclaurin series. So let's do that. Okay. So we go check how the Maclaurin series is presented. So this is how it's presented. Let's go and even cut the question. Cut the question.
I shall want a Maclaurin one day.
All right. So then we have this. So now they say expand in a series of powers of x using the Maclaurin series. So this is the Maclaurin series, meaning that you see they don't even tell you where to end the expansion. You guys, on how many
Yes,
terms
ma'am.
and whatsoever. You see that. So you can do 3, you can do 4, you can do 5 if they don't tell you. So in this case, in our study guide, they did 3. So let's just do 3 as well. So let's do that. So we know that our f of x, I wasn't using blue today. I wasn't using red, I was using blue. And now I can't even choose blue. Alrighty. Alrighty, there we go. So we have f of x is equals to sine of x. Now, according to Maclaurin series, you evaluated 0, f of 0, so then that's f of 0. We know sine of 0 is what, guys?
0.
My first year is 0. Thank you. My first years knows these things without calculators. So then they say you have f of prime of x. So that's f of prime of x, which is, what is the derivative of sine?
Cos x.
Cos x.
That's it.
Then we have f of prime of 0 is equals to cos of 0, which is equals to 1. Now, what is the third derivative here? Second derivative, sorry, of x equals to?
Negative sine x.
And then f of prime of 0 is equals to negative sine of 0, which is equals to 0. Now I don't know what I did. Okay. I'm not liking what's happening now. Okay. Minus sine of x, f of prime of 0 is equals to 0. And then we go to the third one, f of prime of x is equals to minus cos of x. And we know f of prime of 0 is equals to negative 1. Are we all okay up to that point?
Yes, ma'am.
Yes, ma'am.
Yes, we
So
are.
then they say, okay, fine, go and substitute. I don't know why this thing is moving, guys. I really don't know why it's moving. Okay, I'm not liking what's happening. Okay, let's have a new. I think I'm tired as well. Okay, so then according to my Maclaurin series, so okay, let me just write this very quickly. So we have f of 0. We know that, so that's f of x is equals to sine of x, and then f of 0 is equals to 0. F of prime of x is equals to cos of x, then f of prime of 0 is 1. Then f of prime of x is equals to minus sine of x, and we know that prime of 0 prime is equals to 0. Then f of prime of x is equals to minus cos of x. Then f of prime of 0 is equals to minus 1. Do you see how fast I was writing? You write very slowly in the exam and you don't finish. I'm learning to write fast as well. So according to Maclaurin says, this is where you need to substitute. So then f of x is equals to f of 0 plus x times f of prime of 0 plus x squared over 2 prime times f of prime of 0 plus x to the power of 3 factorial prime of 0 plus ... to show that the Maclaurin series, this is an approximation, so you are showing that it's continuing. Then you can say f of 0 is 0 plus x times 1 plus x factorial times f over 3 factorial times f prime at 0, which is negative 1. Are you all getting that, guys?
Yes, ma'am.
Yes, ma'am. So, ma'am, so this is basically very similar to the binomial theorem.
Yes, but then yes, very similar. Very
Okay.
similar.
I noticed that.
Are we all okay there?
Yes, ma'am.
Yes, no. Okay,
Yes.
so then this is equals to 0, x, 0, plus, did I miss something? X to the power of 3 over 3 factorial.
There should be a minus there, ma'am.
Yes, minus. Or 3 plus ... Are we all okay there?
Yes, ma'am.
Now one can ask me, why is it different from the study guide?
They just did more
Because,
terms.
thank you, they just added more terms. That's it. So they went to the fourth one and they went to the fifth one as well. They just added more terms. Are we all together?
Yes, ma'am.
Yes, ma'am.
And that's the Maclaurin.
Yes, ma'am.
And that's the Maclaurin series. Is there someone who didn't understand it properly? Is there
Well,
someone who didn't understand it properly?
maybe because I didn't go through the study guide up to this point, but I was expecting more. I don't know I don't know if it's just me.
I think because you did the difficult things and you come to Maclaurin and you're like, I'm expecting more from you, Maclaurin. And you didn't get more.
And the name itself,
Of course. I want a Maclaurin one day.
So there are Taylor series, other forms of series, as you said, sort of the binomial expression, and well, there are other forms of that, but in here we're only doing the Maclaurin series, right? And at some point you'll be asked to find the general. Okay, let's not talk about that now. We might remind me to talk about that in the revision. So this is what you're doing basically. Are we all okay, guys?
Yes,
Should you
ma'am.
do another example for it?
Yeah, another one will be much more helpful.
Okay. let's go and do this, the other example. Okay, I think I need to take the formula again. Here's the formula. Do you remember what factorial means, right?
Yes, ma'am.
Yes, ma'am.
Okay, there's the formula. And which example are we doing now? So
Can
we're
we do
doing-
number 3, ma'am? Because number 2 is to the power of e.
I didn't want to do number 3. I wanted to leave the difficult ones for you guys, but let me just do it. Okay, so how many times do you want us to expand?
4.
I'm not doing 4.
Able.
I'm not doing 4. So how many times?
3.
3.
Okay, let's do 5.
Oh, okay.
Okay, so now we know that our f of x, so I'll be very slow here and maybe even choose a red color that this class prefers. So f of x is equals to ln of 1 plus x. Are we all together there?
Yes, ma'am.
The first term says evaluated 0, so meaning I evaluated 0. Then I have ln of 1 plus 0 is equals to, what is it that? This is equals to 0, right? Ln of 1 is 0. Now the second one term wants me to find the derivative and evaluated 0. So the derivative of this, we remember the derivative is 1 over 1 plus x times the derivative of that, that's 1. So meaning that this at 0 is equals to 1 over 1 plus 0, which just equals to 1. Now, the third term says this multiplied by that, so meaning I need to find 5 prime. Why am I saying 5 prime? So this is equals to, help me. What is the derivative there? Hello?
We use the quotient rule.
So that'll be?
It will be leave the bottom as 1 plus x and square it. Then it's 1 plus x at the top. Times the 0.
I'm not writing it because I want you to simplify it while you are doing it.
That will be minus 1.
So then f of 0 equals to minus 1 over 1 plus 0 squared is equals to minus 1. Third one. There we go. Third one. So this is equals to, what will be the third derivative? Guys?
It's 2 over 1 plus x cubed.
So that's 2 over 1 plus x cubed. Then we go and evaluate. Remember I told you that I won't be showing you how to differentiate later on when you do the application. So that's 2, 1 plus 0 cubed, that's equals to 2. So how do you think the next one will look like? Okay, so it's f of the fourth one. I'll do this. Fourth derivative is equals to what? I don't remember Roman figures, so I'll write 4. And then
2 over 1 plus x to the 4.
So then the fourth one, are we all agreeing on that one, guys? Did you check?
Let me double check.
And then the fifth derivative,
3 over 1 plus x to the 5.
I'm writing what you guys are telling me. So if it's wrong, you have to double check because we are in the discussion class. Are we all okay up to that point, guys? Hello?
Yes, ma'am.
Yes, ma'am.
Why is it when I use chain and power rule, I'm getting 8 over 1 plus x to the power of 5?
Why are you getting 8? From where would you get your 8?
Oh, because I used power rule and I multiplied -2 with -4. Or let me double check.
Let me see what you... So you're saying here, yeah, it's not a 3. Is number 4 correct, guys? Hello? Because number 5 is definitely not correct. Guys, please verify. I know you are tired. Oh, sorry. I do apologize. Because I see what you mean when using the chain rule. Check number 4 and number 5. Is it correct?
Yeah, I'm checking number 4 now.
All right.
Before I got -6 over 1 plus x to the power of 4. Wait, what am I doing wrong here?
I don't think you're doing wrong.
No, I think he's correct.
He is, because I'm looking at, he's using the chain rule, and this is how the chain rule will look. So this is -6. And this is -8, +8. No, it won't be +8. It'll be what?
It's 4 times.
Oh, it won't be positive because number 4 was initially wrong. So yeah, the workings will be different now.
Yeah.
So it'll be what?
Let me read.
-24.
24. Yes.
24, sorry. Not -24.
Okay, so now this looks much more better. So this is what, -6, and this is +24. Did you guys verify?
Yes, number 4 also got -6
Yes,
over 1 plus x.
Okay.
4.
Thank you. Thank you. So then number 5 will also be correct. Now from here, they say that the Maclaurin series expansion will be like this. Isn't that the first one is f of 0 plus x times f of prime of 0 plus x squared over 2 factorial times f of prime of 0 plus x to the power 3 over 3 factorial f of prime of 0 plus x to the power 4 over 4 factorial times f to the power 4 of 0 plus f to the power 5 of 0 times x to the power 5 and then 5 factorial plus ... to show that it's continuous. Then we go and say f of 0. What did we get? F of 0. F of 0 is 0. So this is 0 plus x times f of 1. F of 1, we got 1 plus x squared over 2 factorial. F of prime, we got -1 plus x to the power of 3 over 3 factorial. F of prime, we got 2 plus x to the power of 4 over 4 factorial. f of prime of the fourth derivative, what did we get? We got -6. And then plus x to the power of 5 over 5 factorial. Then to the power of, we got 24 plus dash, 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 dash. Are we all together there?
Makes
Yes.
sense.
Okay, so then we don't leave it like that, guys. We don't leave it like that. We simplify it. We simplify it. So let's simplify it, simplify it. So meaning that this is equals to, so this is 0, and then we have x plus, so minus x squared. We know 2 factorial is just 2, and then we know that plus 2 times x to the power of 3, 3 factorial, we know it's 6, minus 6 times x to the power of 4, we know factorial 4. What is factorial, guys?
24.
24. It's 24 plus x to the power of 5 times 24 here over, what is 5 factorial?
120.
120. So this is equals to x minus x squared over 2 plus this is 3. So x to the power of 3 over 3. This is 4. So minus x to the power of 4 over 4. And then how many 24s are in 120? But it leaves a remainder, does it?
It's 5, ma'am.
So then we say plus
5.
X to the power of 5 over 5. Can you see that, guys? Hello?
Yes, ma'am.
Yes, ma'am.
Yeah, that's the Maclaurin for you.
Plus dot, 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 dot to show it's continuous. And from here, you can find a general formula where you have the sum of from I equals to what, then whatever. You don't have to know that for now. Yeah, let's say you don't have to know that. I don't want to bring something in the exam, which
So,
is not
ma'am,
in the exam. Yes.
So if you do ask us this, will you tell us how many times do we have to derive it, or you just leave it ambiguous?
I'll have to tell you because some of you are crazy and might derive up to 20 because you're excited. So I'll definitely tell you how many turns.
Ma'am, if by chance you don't tell us, do we assume that we do 3 terms and then dot, dot, dot?
If by chance I didn't tell you, it means that I was crazy when setting the exam because I have to tell you.
Okay.
It means ma'am's like 20 pages of one question.
I
Otherwise,
definitely have to tell you. Otherwise, then send me an email, then I tell you during the exam. Yes, so because okay, let me not talk. Is there any question regarding the work or should I stop the recording?
I'm fine on my side. Makes sense.
All right, I'm stopping the
Okay.
recording.
So you said we didn't have to know to the nth term.
Not for now.
Okay.
I'll still have to, yes, not for now, because I see it's not in your study guide. So then I'll see if I have to teach or not. But it will be nice to know up to the nth term. All righty.